analysis, and I can see that all three of you have justified yourself quite convincing. Okay, that's nice. So I would like to give you, let's see, perhaps, okay, how about feasibility study? Okay, for feasibility study, there are two questions. In which phase of the SDLC life cycle is a feasibility study? And the second one, you need to explain the importance of a feasibility study, okay, in the context of SDLC. So you can include any website link or any short YouTube video to accompany your answer. Okay, so this is a collaborative learning. I'm using YouTube video for collaborative learning in Google Classroom, where you can reply to each other. Accompanying my question is a YouTube video on feasibility study, 1 minute video. So you can edit your answer, you can reply to your friend's answer. Okay, let's see. I give you, today is 15, right? Okay, until tomorrow. Okay, so I click ask. This is for your class activity. Okay, so you can see this is due tomorrow. As for the tutorial, this coming Thursday, I'm not sure whether my class will be affected by the MQA virtual audit for our diploma in IT, the DFT students. My class with you in the afternoon. I'll just I still need to be standby lah. Okay. But for this coming Thursday, you will answer tutorial 8. Okay, tutorial 8. What we have covered last week under system development, programming and tools. So this time we rotate again. Question number 1, Calvin. So you explain why we maximize cohesion, and then as for coupling, we minimize coupling in order to achieve a maintainable system. And then besides cohesion and coupling, any other design attribute that might influence the system maintainability. Okay, 2 questions in fact. For Noel, you explain why a good design is an important process in SDLC. Okay, and then Kelvin, this one is 2 questions. And then Noel, there's another question here. Question 2, describe what is a case 2. And as for Farah, 2 more questions. Okay, that's about it. 3 ways our case 2 could assist in the development and maintenance of the models. Okay, like we draw DFT or ERD. And another question for you, Farah. 3 ways case 2 can be used in software development. Okay, so this is for your Thursday. All right. Now, for today, then we'll continue with the chapter 9. Okay, if you're ready, because you need to fill up the blanks in your notes, right? Okay, so let's start with our lecture. One moment. I need to remove my second screen. Okay. Right, like what I mentioned just now, this is the continuation from last week. So we'll cover the two more subtopic under system development, which is testing. Okay, testing is done right after coding is completed. And before we go to the next phase, for SDLC, is a traditional approach. We need to make sure that we have our system fully documented. So we will look at the four types of documentation here. Right. Regarding testing the program, I believe you all understand what does this diagram means. Okay. When you are done with your program, when you do compilation, then you will get the object program, the .obj or .exe. Okay, and then after you have this object program, then you can run your program, and then you will see output being displayed on the screen, right? The translation of the program happens when we are here. Okay, we want to translate the program into executable machine codes. Therefore, we can execute the programs or run the program and then see the output. This is where, okay, we can see the syntax errors. Okay, when we translate the program into executable machine codes, this is where we can see the syntax errors. Something like grammatical errors, but then for programming language, perhaps there's some rules that have been violated. Okay, and then not normally, a programmer must correct all these syntax errors, because there are syntax errors, it will not be translated properly into executable machine codes. Programmer should eliminate the syntax errors and then redo the compilation. Okay, so what you see on the left-hand side, compilation process is translating the program into executable machine code. Now, the next step would be what we call as test checking. Test checking means, as a programmer, you read through. Okay, you read through the program visually, right, and mentally reviewing the logic of the program. This is quite difficult for us to detect errors, because you need to mentally view the logic and then foresee whether it will work or not. Okay, this is test checking. Now, there's a more formal way of performing test checking, whereby we call it as a structured walkthrough. Okay, when we do a simple test checking done by one person, okay, done by a particular programmer, that is individual effort, okay, from the programmer himself. But then for a structured walkthrough, as what you can see in this picture, this is where the software developer or the programmer will present his program or his module. And who will be the audience? It will be other programmers, it can be other system analysts, perhaps they might include users as well. Now, what is important during structured walkthrough, we need to have a chairperson and a recorder. Normally we call it as a recorder, but another name for recorder is a secretary, whereby chairperson will be sharing the overall structured walkthrough meeting, and the recorder will record the something like a minute, okay, a minute of the structured walkthrough. And what's happening during the structured walkthrough meeting is that the audience, okay, they are trying to detect errors. or trying to see whether the programmer follow or adhere to their programming standards. And then if the users are there also, to verify whether the program can satisfy the user's requirement. Okay, so this is much more formal, right? This is a much more formal with audience from other people. Okay, now that we have looked at the typical testing done during the coding phase, okay, like we translate the program, meaning this is where we compile and then we can see the syntax error. And then there's a test checking performed by a single programmer, which is a bit difficult. And then there's a more formal way of test checking. We call it as a structured walkthrough. Okay, now we look at the three major types of testing. Okay, so the first one you can see here is the unit testing. Okay, assuming that we have this program that will call two modules here depending on the option selected by the user, right? And then as you can see, if the user select the second one, then there's another option. As this is just an example, right? So unit testing for each of the modules in the system. And the second one is a link testing. As you can see, we have one, we have two, we have three link testing. This is because we want to see whether this module 1, module 2, module 3, they work properly or not. Okay, whether they are linked properly, whether they are integrated properly, means the output from module 1 can be passed to module 2 as well as module 3, and then we also want to see that module 2 will be able to get input from module 1, module 3 will be able to get input from module 1. So as long as these modules, they depend on each other. For example, passing output to another module or getting input from another module. So we need to perform the link testing. Like in this case, unit module 2 and module 4, they are linked, meaning module 2 will pass the output to module 4 and module 4 will need input from module 2. So here, this is another link testing that need to be done, okay, as well as here. Okay, so three link testing. And then the third major type of testing is the system testing. System testing means we test the overall system as a whole, means starting from we logging into the system, we enter data, perform some transaction, we display some output like a report, and then we log out from the system. Okay, so that is the overall system testing. This is what we are going to cover this few slides after this: unit testing, link testing, and system testing. Now, the definition for unit testing is given in this slide. It means from the word unit, okay, we want to make sure that each unit, normally we call it as a module, okay, to make sure that each module functions properly according to the program specification, right? When we perform unit testing on this individual module, we can identify if there's any execution errors, whether there's any logic errors, and whether there's any syntax errors. Now, do you all know what's the difference between a logic error and a syntax error? Anyone? Logic error and syntax error? What's the difference?
Logic error that can still be run, but the answer will be not correct. So syntax will be the whole program cannot run the
Yeah, you are correct. You describe it correctly. Syntax error means there's a problem with the code itself. Therefore, translation cannot be done. All right, you need to fix the error before you can even run the program. As for logic errors, there's no syntax errors, compilation errors. All those we can run the program, but the problem is, oh, logically the output is not correct. Okay, that's good that you'll still remember that. Okay, now let's get back. So programmers will perform this unit testing on their individual programs or individual module, and normally they will use dummy data lah, okay, or some values to make sure that the program can handle the input correctly. All right, handle the get the input, do the processing, and then display the output that they want. Right. Now, are you aware of the term stub, STUB, stub testing? Have you heard about stub before this?
um
No.
so no, haven't. No.
Haven't, but I think you might have used this before, stub testing, whereby like in your assignment, okay, you have one question, Farah, you're doing module 1, Kelvin doing module 2, Noel doing module 3. But then before you can combine your codes, there's a main menu. All right, from the main menu where you will select, okay, which option to run first. Okay, but then if you're doing your own, you don't have the other friends code yet. So what you can do is you put in a stub there, an empty function or an empty method. Perhaps just do a display like function 2 by Kelvin under construction, something like that. Meaning when you run the program starting from the main menu, like Farah, you select your own option, then you can test your program whether it works or not. But then for Kelvin's and also Noel's function, you don't want to be like, okay, like if I click on that, or not click, enter, select the option for their program, right? You don't want to get error message. So what you can do is put an empty function, a call to empty function, just a display of output, still under construction, something like that. Now, let me go back to my slide. So the definition is given here. It's a piece of code written to emulate a module or a function, or in a simple way, to stand in for the missing module. Okay, so the purpose is to test programs that interact with other programs and files individually before they are integrated into the system. Like if we go back to here, like say this is the main menu, right? Okay, this one is done by Farah, this one done by Kelvin. Okay, so Farah can select the option, go to his program, so he can do that. But then if he select the option to go to Kelvin's program, is not ready yet. So what you can do is put a stop there. Okay, like there's another example given here, example of a stub program. This is involving two different systems. Say you are in charge of the inventory systems receiving goods module. And then you know that in order to receive the goods, you need input from the purchase order. Okay, and purchase order is from another system, purchasing system. So what you can do is that to emulate or to like mimic the actual purchase order, you pass in hard-coded data. Okay, like this purchase order, what are the data for the purchase order? You pass it as an input to your receive goods function. So at least you can test out that the receive goods modules that you are doing can function properly or not. Okay, so this is an example of a stub program. In case you are not clear about that, I have this example from my diploma course, okay, programming in C. Okay, normally we will use the stub program when we have some kind of menu. All right, some kind of a menu, like here we have addition, okay, and then another code for subtraction. So imagine that you're doing addition, but then another friend is doing subtraction. You don't have codes for subtraction. What you can do is okay. Then what you can do is you add the subtraction function as a stub, right? As a stub in the program. So an empty function. You will come up with your own coding, but then for the subtraction, void subtraction, you just do a printf under construction. That's it. Okay, as simple as that. Okay, functions without implementation. Now let me get back to my slide. Now, the second major type of testing is a link testing, also known as integration testing. It doesn't only involve one particular module, but it involves at least two or more modules. Okay, and then how do we know how many will be involved? As long as these modules, they interact with each other or they are dependent on each other. Okay, because we want to make sure that the data can be passed from one module to another module or from one program to another program, like what we see here. Okay, data can be passed from one program to another program, right? And then this is still done by the programmers. As for the test data, I'm still using dummy data lah. Okay. Now, the third major type of testing is the system testing. Now, look at the first one. Number of programs or number of modules involved. The answer is all of them. Okay, all the modules. Let me go back to this one. So if you have like 7 modules, then for system testing, you will perform the testing involving all 7 modules. For unit testing, okay, if you're performing unit testing for the module 1, then it's only for module 1. Okay, and then the next one is for module 2, module 3. So how many times you need to do the unit testing? You have 7 modules, so 7 unit testing for each of the modules. How about the link testing? Link testing depends. As long as the modules, okay, they are dependent on each other, then you will do one link testing. Like 1, 2, and 3, one link testing. 2 and 4, another link testing. 3, 5, 6, and 7, another link testing. So 3 link testing for this example, and system testing is a whole, so all of the modules or all of the programs. Okay, now, so the purpose is, since you are testing the whole program, we want to make sure that the individual program or modules can work properly as an entire whole system. And then here, If you refer to unit testing and link testing, both are performed by programmers themselves. But for system testing, we need the end users, we need the operations group, and also the project team to conduct the system testing, whereby this time we are no longer using dummy data, but we are using live data or real data supplied by the end users. Last time when I did my internship, okay, quite a number of years ago, there's a sense of like, oh, this is scary. I'm touching the real data. I hope I don't get the data corrupted, or I cause any major mistake or something. All right. But then my project manager at that time, okay, he told me, do not worry, okay, you just continue with your coding, and then you can test using the live data. These are live data, meaning it's not a data that I simply key in Ali, Ahmad, Abu like that, a live data, so that I can test the code, whether my code will function using the actual data that normally the end user will type into the system. Okay, whether my code can still function, or will it crash with all this data that I cannot think of when I test my program using my on dummy data. Okay, so my project manager told me, do not worry, Melissa. I have duplicate the live data, and then for your coding and testing, it's you will be using the even though it's a live data, but then it's not actually live, because I'm not touching the data that the user are using. Okay, it's like a screenshot of the database. Okay, just for the sake of testing. Okay, done by last time how many programmers? Myself and another senior programmer. Okay, the feeling of getting to test your program using live data is something that is, I think, every students must hopefully you all can experience this during your internship. Okay, live data.
Very stressful.
Once, yes.
Is it very stressful when you try to do the live data?
It's not that stressful, but there's because my project manager, he already mentioned to me that this is not the live data, but he already duplicate it on in our server. So what myself and the other senior programmer, what we're touching is just like duplicate of the actual data as of that particular day. The duplicate is made. And then what's interesting is that when you look at the live data, then I didn't even thought about typing this as a dummy data. Or let me check whether my program can handle this type of data. Okay, so because you don't have the like experience working in that particular end user department, so your dummy data are quite limited actually. Like you can like type 1 2 3 4, but you cannot just type 1 2 3 4. All right. Sometimes you remember last time when we learned about the system design. Okay, the input validation, there's a range check. Okay, so for us, or simply type 0, negative, but then will it be able to like handle until how big? Well, what is the limit and so on? So that's the beauty of using live data lah. Okay, live data, where we will get the data from the end user. Do you all know in which semester you all will be doing your internship?
Semester 8.
Semester 8. So now you are 1 2 3 4 ka? Sem 4?
Now it's 3.
Oh,
Three.
still in 3. 1, 2, 3. Oh, lama lagi. So this is your time to like pick up as much a skill that you have, like programming, a database you already have, and then perhaps now you're doing visual programming. Okay, so you still have time. Okay, let me continue. For system testing, it will involve the end users, part lah. Okay, but normally, like in my case last time, the project manager, before giving the end users the operation group to test the system as a whole, they gave it to the programmers to use the live data for the link testing or even the unit testing. Okay. So this is an exercise. What you need to know is how to compare them. Okay, unit testing, system testing, user acceptance testing. I think we haven't covered this one yet. Okay, let me check where's the... Oh, user acceptance testing is here. Let me cover this one first. Okay, user acceptance testing. The main purpose for user acceptance testing is we want to find out whether the system meets the requirements listed in the SRD or SRS, the requirements specification. Remember, I hope you can still remember system planning. The output is the preliminary investigation report, and system analysis, also known as the requirements modeling. So the output from system analysis is the SRD, system requirements document or system requirements specification. So based on the user's requirements that SA obtained during the system analysis effect finding, we will see whether this working system means completed system, whether it meets the user requirements. So the user themselves will check whether the system does what they are specified, and then the test data is no longer dummy but realistic data. No longer Aliamat Abu, but perhaps a proper name, Siti Saleha binti Muhammad, something, okay, realistic data. Areas of test, because this is user acceptance, they will focus on usability, okay, whether the business process are properly reflected in the software, and then they will give feedback to the system analyst of any problem that they encounter while using the system or any difficulties, right? And then sometimes this one is like, or you will be wondering, if you are the programmers, oh, I've already done the unit testing, and then I even done the link testing. But then somehow users, when they use the system using realistic data, they are able to find errors which exist but not yet been detected. The reason is because of this. They're using realistic data based on their day-to-day operation. Okay, and then besides that, they can also find out exactly what the demands of the new system are, right? Because as a software developer, we are not the end users. So when we develop this, unless you have experience in that particular department, okay, then you can at least expect something. But somehow we don't know what is it. That's why in order for you to be a system analyst or a project manager, you need minimum, say, 3 years of experience, okay, because of this, right? And then while the user they test this system as well, this is a user acceptance testing, they can see whether or not there are any major changes in how they operate day-to-day operations, whether they need to change how they the day-to-day operations or not. Because for a software developer, sometimes when you want to automate certain business processes, you need to make certain changes. Okay, certain changes. So these are some of the things that we can find after the UAT has been completed. Okay, so examples of or types of acceptance testing are beta testing, and then we have benchmark testing, then we have the alpha testing and parallel testing. Okay, now let's start with beta testing first. Beta testing, we will select a few end users or customers. Okay, normally these customers or end users, they agree to use or test the system at their own premise, means using their own PC, laptop, and then give feedback. From what you read here, this is a typical way for how to explain for commercially available software packages to do their testing. Okay, they will select customers, right? Or end users, and then these end users, normally they themselves who are willing to do the testing. Why? Because they get to use the latest version of the software. And then for benchmark tests,
do the customers need to sign anything before they do the beta test?
It depends on the company, but then the one example that I always see is when you're using the mobile app for a certain software, like what was it already? Like Facebook app. This is a mobile app software. They will say, "Oh, become our beta tester," and then I never click the link lah. Have any one of you clicked the link to become a beta tester?
I think for me, I beta tester for the apps Instagram. I think.
Oh, Instagram. So
Yeah.
is there any like you need to sign or acknowledge something?
Back then I don't have. Just click here to become beta tester. Then it automatically be beta tester lah. Yeah, like that.
They want to make it simple. Because if it's too much of a hassle, then they cannot reach a wider audience to do the acceptance testing for their software. Okay, the customers or the end users themselves to agree to do the testing. Okay, and then provide the feedback. Okay, you can see here that with this beta tester can expose a product to real use and detects errors. Okay, or come to think about it, I remember one of our diploma student already graduated. I think he won a MacBook. Was it a MacBook? Because he gave his feedback on he found bugs, okay, errors in the I cannot remember already. Google. Cannot remember, but he won his MacBook, so he brought his MacBook to our our lab. So he's not using the computer the lab computers at all. He's using his MacBook. Then after that Yeah, and then he found another one, and then it's like he got another like prize, a gift lah, a gift. So I guess the error that he detected was quite how to say with the impact will be very devastating. I also don't know. All right, quite a big company. How come I cannot remember what's the company? But I remember his MacBook lah. Okay, and then that is beta testing. For benchmark tests, here they are using test cases that represent typical conditions. So test case to test a certain condition, and then normally to evaluate the performance. Later we will look at the operating performance. Okay. Another one is alpha testing. So is this the same with beta testing? Alpha testing, it's performed in-house. It's meant for a single client. So just now I mentioned beta testing is meant for the commercially available software packages or mobile apps like Instagram. Everyone use Instagram. For alpha testing is meant for a bespoke system, means a system developed from scratch for a particular company use, okay, for a single client at the software developer's premise. Means the testing is meant for a bespoke system, but then not done at the end user's company, but done at the software developer's premise. Here, what they're trying to do is that they want to simulate the real environment, okay, the real environment while doing the alpha testing. And then there's one more listed here, parallel testing. When we cover system implementation phase, one of the system changeover method means we change over from the old system to the new system. We have 4 types, and then one of it is parallel changeover. So what happened during the parallel changeover means when should we stop the parallel implementation of old system and new system together, and then decide one day to stop using the old system and just continue using the new system. It depends on this parallel testing. It means the testing will be performed when both new and old system run concurrently. Okay, they want to achieve, okay, where both systems, they are comparable in terms of the output or the result that can be produced. So it means if the new system can produce the same result like the old system, it means, okay, the new system is ready. So since we can say that the new system is able to produce the same result as the old system, it's time for the old system to be terminated. Okay, that is parallel testing, normally conducted during the change over from the old system to the new system. But this parallel changeover is only be done when there's a budget. Okay, when there's a budget for this changeover, because to operate both old system and new system for a certain period of time, it involves some cost. Okay, you imagine your end user, they need to enter data into the old system, and then at the same time they also need to enter data into the new system, right? But they need to see whether the same output can be produced, right? So only happen when it is fully budgeted. But then this is very useful when the system being involved is quite a critical system, like online banking. okay, a banking system where if insufficient testing is not done, then it will affect real end users, then that is not what we want. Okay, so that is acceptance testing. Okay, so let's go back to this exercise. Okay, so you need to differentiate between what is a unit testing, system testing, and user acceptance testing. I believe you can easily find what is the purpose, who perform, the test data used, and the areas covered. Okay, so let's take a look at the answer. Unit testing is to make sure each unit of the module or functions works properly. System testing, we want to test all the individual programs work as a whole system. And for the UAT, user acceptance testing, is for the user to see whether it works and achieve the requirements as stated in the system requirement specification. Okay, unit testing is done by programmers. User acceptance testing is definitely done by the users, and for the system testing, done by this group of people. Okay, the end users, the operations group, and also the project team. Okay, unit testing, normally we're using dummy data. System testing, live data, right? And user acceptance testing, realistic data. Okay, areas covered are shown here. Unit testing, normally we look for execution errors, logic errors, syntax errors. These are what the programmers will need to find. System testing, this is test the overall system. So just now I mentioned starting from their login into the system until they log out from the system means they want to verify all the processing options and then see whether the system can provide the output as expected. Okay, and then for the UAT, look at the usability, right? And then give feedback on whether there's any problems or difficulties when they're doing the testing. Right. If the question asks you to compare or differentiate, it's much more easier if you put it into table, but make sure the sentence that you put there is a complete sentence. All right. Now, what is the scope of the system testing? Because here, if we go back, we want to make sure that individual programs can work properly as an entire whole system. So now we look at the scope. It involves the system interfaces. It means whether can correctly pass data from one program to another program. And then it also includes the functionality, can make sure what all those business processes mentioned during the analysis phase, design phase are correctly implemented in the software. That is why during system testing, we have all these three groups of users, the end users and their operations group, and then the project team. Okay, project team would be the software developer team, right? So they need to make sure that what they have during the analysis and design phases of the SDLC are correctly implemented in the software. And then it will also include performance, volume, or load testing. Okay, here when we look at the performance, volume, or load testing, this is especially important when it is if we foresee that it will be used by like a big number of users. Say it's an online system. Okay, we want to make sure that the system will not fail when too many users login into the system, perform transaction at the same time. Okay, so you can read on here. Make sure it can deliver the required performance when handling volume of transactions, means processing a large number of transactions. Okay, the size of databases. This is where we need to have quite big capacity for our server, database server, and also handling number of users at the same time. Okay, and two more scope of system testing would be the usability. Okay, make sure they are consistent, adhere to the industry standard, it's clear, and then there's useful or meaningful error messages. These are all mentioned in our system design when we first covered the user interface design, okay, the user friendliness characteristic. Now, stability and reliability. This is to make sure that if there's any error, you should be able to inform your user what's happening, rather than the system just crash and then the user, they don't know what to do. At least if there's some error, the best thing that you can do, if it's like unexpected, you need to catch the exception and then throw a message to your user. Nowadays the error messages are very nice. Oops, something happened. We'll try to resolve this. Okay, and then do you want to go back to the main menu, something like that. Okay, ensure that error reporting messages are correct and appropriate. So during this system testing, the system tester will enter values that will cause the system to fail. A correct way to do testing, like what I normally tell my diploma student. Okay, I will tell them when you submit your assignment, this is how I'm going to check your program. I will try to fail your program. Like I will simply enter ABC, even if you tell me, please enter an integer. I will simply enter ABC, yeah, and then I will try to fail your program, something like that. Okay, enter values that will cause the system to fail. I'm not sure whether you'll have covered system testing during your first course, programming first course. Have you covered any system testing?
Not sure.
Like there's a test cases, enter this input, okay, supposed to show error message, but then you, if you are the tester, then you will need to mention whether error message is shown accordingly, or system crash, something like that. Did you do that for your assignment?
Or like display error, like you input. I think have.
Yeah, that is one example of a testing, like a unit testing, where you have all these cases, like valid login, okay, invalid login, what is your expected output, and then what is the actual output, okay. And for software engineering students, okay, we do have DSF students, diploma in software engineering. They are more specific, okay, for software engineering students. They learn one whole course just for system testing. Okay, for diploma, they learn introduction to software testing, and in degree, they will take more advanced, where they learn more about the system testing, as well as QA, quality assurance, means how to make sure that the program that they develop is of high quality. Okay, for us, we learn about, okay, these are the 3 major types of testing, and that's it. For software engineering, they need to learn more than that. Okay, let's see how many more do we have. A little bit more, then I will give you all a break. So let's finish off as the testing of program. In the scope of system testing, one of the scope is to check on the performance or the volume or the load testing. So we will look at that. Performance testing, also known as load stress volume testing. What does it mean? It means we want to put our system under extreme conditions. Okay, extreme condition, we want to find out what is the limit of our system's performance. For example, in terms of volume, perhaps handling of transaction, can it handle 60,000 records? In terms of number of users, what is the largest, highest number of users it can handle at one time? Get the network traffic. So to do this, we cannot like get all our programmers to do this performance testing, because we cannot get the number of users that we want. Like previously, when AirAsia first introduced their marketing strategy, zero, what was it? Zero fare. What is it? The zero fare? Cannot remember. Zero fare, and then everyone can fly. Last time there used to be a zero fare, and we only need to pay the airport tax. Airport tax is like 50 ringgit to Thailand and so on. When they introduced that, you know what happened? Their online ticketing system cannot handle the number of users. Okay, it crashes. Like one of my ex-colleagues, she tried to book our flight to Thailand, and then yeah, I cannot. I waited until midnight, still cannot log in. It seems that that is the peak hour. Peak hour means too many users trying to get the zero fare ticket. And then the next day she told me, oh, I waited until 3 a.m. finally can get through. Means login and then pay, make the payment and everything. So it's quite difficult. But then I see that throughout the years, AirAsia, they have been like upgrading the system from time to time. We can see that in the news article. And to do this performance testing, can you take a look at the third bullet here? We need to use specialized simulation software. Okay, a simulation software that can simulate a big number of users, that can simulate a large number of network traffic. Okay, to simulate like 60,000 records, okay, being performed. We cannot simply ask human programmers or end users to do this simulation. So we need a software, okay, specialized software. Now, the purpose of the performance testing is mentioned here. Like for performance, we want to see whether the system can meet the defined performance objective. Remember when we learn about the system requirement, we have functional requirements and non-functional requirements. Okay, performance requirements, we can put it in the like definitely under functional requirements, right? it cannot be under non-functional, because we want a system that can perform like we see the result within 2-second response time, especially when it's an online system. I read this somewhere, or perhaps I watched a documentary for a South Korean. If they click on a link, okay, a website link, and if it does not properly displayed within 4 seconds or 2 seconds, they will give up and then go to another link. Okay, because for them, they have like one of the best internet connectivity, and if there's nothing wrong with the internet connectivity, but then the system itself, it's like quite lagging, they will not use that particular system. Okay, there's for us here, 2-second response time is like, wow, oh lajunya. How long will you wait for the system to load? 5 seconds? 10 seconds? How long
yeah.
will you wait?
5 to 10, yeah.
5 to 10. Then if it's take a longer time, then I will look outside. Or is it cloudy? Is it going to rain? Because for mobile broadband, it can be like what do you call that? Affected by weather, okay, interference and so on. Right. So at the end of the day, for performance testing, we want to see whether the system can perform within the predicted data volumes, network traffic, and number of users. Quite impossible unless you have a specialized simulation software. So I believe this is what the software engineering student learn, okay, to do the software testing. Now, importance of load testing, we want to find out the limit, and we want to do a prediction of the performance requirements, and then we want to find out earlier on in advance what is the potential effect of when all this happen. Will the system straight away crash, or will the system still functioning, but it becomes slower and slower, and then eventually will it crash? Or will the system able to display an error message or a message? It seems that our servers are having unexpected volume of traffic. Please hold on for a while. So we want to find out the potential effects. Okay, so these are the 3 importance of load testing. Examples of performance testing for order online. We want to see the potential effect of the increase in number of customers accessing the website at the same time. Especially now we have the Shopee, Lazada. Okay, once a month there's this promotion, right? Okay, I believe they have their own like team to look at their system online performance testing. And then for point of sale system, this is used by supermarkets, retailers, okay, hypermarkets. Determine the effect of the performance when there's an increase in the volume of transaction at the checkout point. Let me see. Okay. I saw this particular show in Astro. Cannot remember what was it already. Extreme couponing, something like that. And the point of sale system, in fact, crash because it cannot handle certain number of coupons. Okay, I think this one is in US, where this extreme cheapskate, they call it, instead of using money, they collect all these coupons. So when they do a checkout, instead of paying cash, they just like pull this large bunch of coupons and then get the cashier to like scan all these coupons. But during the show, it seems like it's a show to let's see whether I can crash their POS. Okay. I don't know. I think they're happy that the system cannot handle my coupons, something like that. So I can see that the manager, one of the in one of the show, the manager, she didn't panic, but she instructed her cashier, okay, to like split the transaction into two. Okay, so it means that that is the highest number of coupons that the machine can handle. All right, that is one transaction, and then continue in another transaction, something like that. Okay, and so this will not happen if what earlier on, right? For the point of sale system, in terms of the lot testing, they already explored the potential effects of what? Large data volume. And in that case would be the number of coupons that it can scan. Okay, but then who knows? People can become such extreme cheapskate, yeah? They bought like how many trolleys of items, okay, and they only pay several dollars for it. Okay, have you all watched the show, the extreme couponing?
Oh no.
No, it's quite like if I'm the software developer for the point of sale system, I think they didn't expect that there's a human who are willing to like produce like hundreds and hundreds and hundreds of coupons just to pay their groceries. Okay, or if I am the manager of the supermarket, then I need to think about my business process. Okay, so let's check here. I think it's mentioned somewhere about the business process. I think it's under user acceptance testing. Okay, like if the supermarket, they purchase the point of sale system, was it already? This one. Okay, find out whether any major changes in operating procedures will be necessary. Say the supermarket, they purchase this point of sale system from this software vendor, and before that they conduct the user acceptance testing. When they do that using realistic data like the number of coupons, and then it crashes. So perhaps they need to think of do they need to impose any changes in the operating procedures? The limit of coupon is like until 100, an example. Okay, so that is lot testing. And for the lot testing here, already mentioned we need simulation, specialized simulation software. Let's go to that. Oh, before that, there's one more exercise, right? The difference between alpha and beta. For alpha, real environment testing. For beta, to expose to real environment by the beta tester. Carried out by programmers. This one selected customers. For alpha, it's for a single client customized software, but then for beta, this is the commercially available software package or general package. The customer using their own PC. For alpha, at the software developer office. Okay. Two more slides and We're done with the first half. Automation in testing, we need the testing tools because of the cost. All right, testing consume 30% of the software development efforts and also the quality. Um, how long should you perform the testing? Right? Do we need to follow the given schedule, or do we have budget to perform addition testing? So the name of the specialized simulation software, one of it is CAST, C-A-S-T, computer aided software testing. So what it can do, it can repeat test executions. Say you have 60,000 records to be processed. So it can repeat test execution. It can perform the assessment of the performance, testing performance. Can easily see the reports. Okay, there's a simulation of interfaces. The programmer can check the test results. It can include static as well as dynamic analysis, and they can even perform debugging at the same time of the testing. So all these are the CAST, a very good tool in automation or automated testing tools. So the reason why we use this automated testing tool, we want to save time. We can predict the performance, and because of this, allows us to do analysis and eventually do the debugging. Okay, under diagnosing, allow the system tester to feedback suggestion to the system designer. Now, do you understand the meaning of this? In this case, for your information, in the context of software engineering, if you are the programmer, you will do your unit testing. But in a real world, in a proper software house company, they will also have their own software tester. Means software developer, another team, software tester, another team. So the software tester will test the program. If there's something wrong, then they need to inform the software developer, the programmers, right? So that's why when you reach here, allow tester to feedback suggestion to the system designer. Because software tester is another team. The system designer or the system developer, the programmer is another team, right? A proper way of working environment in a software house company. Okay, so with this, now it's already almost 12:45. Let's take a short break because I want to finish by 1:30. How many more slides? Oh, I think I can give you 10 minutes break. So I'll see you after 10 minutes, yeah?
Okay.
Okay.
All right, I'm back. Let me start another recording. So the second recording is on the documentation. Okay, documentation. Okay, I want to show you my previous week slide. Let me open that one first. Okay, let me present my screen. Okay, a recap on what we have covered so far. Last week I've shown you all this. Okay, whereby this is our first phase, system planning. And then this is our system analysis, system design. We are now here, okay, system development, where the software developer or the programmers, they will do the coding based on the system design specifications, the output from the system design phase. So what we will look forward to would be at the end of the system development phase is a completed system, and the completed system then will go through the another phase, which is the system implementation, where the system will be implemented and it includes the system changeover. It means we change over from the old system to the new system, and that will become the operational information system. Okay, just to remind you all, we are here, system development. We are looking forward to a completed system. Right after, let's see, I've shown you all this code, test, and then now we are looking at documentation. Okay, what are the 4 types of documentation? Okay, so let me close this. Okay, so let's continue. A few more slides. Okay, there are 4 types of documentation. You might be thinking, why do we need this documentation? Based on the when was it? Past 2 weeks, Saturday, the sharing by Mr. Bob Jalius on software development. There are 2 types of system development, software development. We have the waterfall model and also the agile model. Okay. One moment. Okay. Still can see, Baran?
Yeah.
Yeah.
It's a system message asking me to I must restart, or if I click OK, I will restart, and then I don't want to do that. Okay. Sorry about that. Okay, so for the documentation for waterfall model like SDLC, documentation is like it's a must. Okay, that's why he also mentioned that for government agencies, they prefer waterfall model because of the complete documentation. Documentation is very important when it comes to the system maintenance. Okay, in the future. Remember when you do your cost and benefits summary, when you do your cost and benefits summary, you do the costing, the benefits for like a number of years, 4 years, 5 years, because we foresee that we will be using the system like for the next 5 years. Okay, maintenance will be conducted throughout the useful life of the system. And in order for us to do the system maintenance, we need documentation to refer to. Okay, and then after the current system has been upgraded or modified, then we need to update our documentations as well. As for agile method, this is quite fast. This system development or the software development is quite fast, that there is documentation, but not as intensive as SDLC. Okay, so what are the 4 types of documentation? The first one is the end user documentation. This is very important when we conduct our training. Okay, when we conduct our training, we need this user manual. We call it as a user manual for our users. Okay, so who will prepare this end user documentation? Both SA and programmers, they can come up with this end user documentation. And then the trainer, if SA will conduct the training, then SA will be using the end user documentation. And then another name for end user documentation is the manual. Okay, the user manual. So look at the purpose: to teach users how to use the software. It can also be used for self-training, because normally it will consist of all of these contents. Okay, you look at the first one, the step-by-step procedures for the data entry, and then it will also show the various types of output, either displayed on the screen or printed out, that can be printed out as reports. Okay, and then if there's any changes or amendment procedures, then the explanation is included here. Right, and then the most important thing would be the error reporting. Error reporting means in the user manual, normally the programmers will include the error messages. Okay, error messages showing, okay, this error message, if you see this error message, it means this, and to solve this problem you need to do this. Okay, a very important part of the end user documentation. Yeah, I think I want to show you one example. One moment, let me find the example. This is from another course, Managing IS for the accounting student. Accounting student and business admin student, they also learn all this documentation, right? Okay, documentation is here. Okay. Have you seen the how do you all know why the errors are called as bugs?
No idea.
The first error is caused by a bug.
Yes, correct. Caused by bugs. Okay, I have another slide here. So this is the first bug. Okay, show you. Testing. Okay, this is the one. So a user manual, it will show the step-by-steps, okay, how to do the data entry. And then not only it includes the narrative or the description, right? It always nowadays involve some screenshot. Okay, then it will be much more user friendly and user documentation. And the one that I want to show you is this one. It also includes error condition, explaining of error conditions. Okay, so this is a screenshot I took from one of the user manual for accounting system. Here it say, if you have not selected you will get an error message. Okay, please refer to the attached illustration. So a good end user documentation also include explanation of the error condition. Okay. The second type is the operation documentation. Okay, operation documentation is done by the system analyst. Okay, system analyst, and it is used by the operations group because normally the operations group, they are the one who will be operating the system. Okay, if there's any execution of batch jobs, especially for like in a human resource information system, like this monthly paycheck processing, all right, or if they want to distribute any printed outputs. Okay, so all these are included in the operation documentation. It will include contents like how to set up the system, okay, the authorization, how to set up the authorization means user can log in into the system. Some user can perform A, B, C. Certain user can only perform A, okay. It means authority lah, all right, the level, access level. Okay, and then some system they have this like previously during my working in the industry, it's quite an old system that once in a while, like once a month, they need to do re-indexing, like re-indexing to do re-indexing. Sometimes they will call the programmer to do that, but then most of the time, the person in charge, means the operation group people, they will know how to do that, like the file dumping, or if there's a system failure, what to do during the system failure, how to recover. All these are included in the operation documentation. Means the people, not the software developer people, yeah, the end users, okay, not the one who will do the data entry, but the person in charge of operating the entire system, starting from setting up the system until the how to handle any recovery. Okay, so must include, SA will include the system messages, so that if there's any certain system messages, explain what does it mean, what they need to do to solve that problem. Okay, so this is operation documentation. As you can see here, end user documentation means meant for the end user who will input the data into the system. Okay, the data entry guys. And then the operation people would be the person in charge of operating the entire system. Okay, third one, program documentation. Now, program documentation, it doesn't start, or it is not prepared during the system development, but in fact, it started much earlier, begins during the system analysis. Okay, so imagine during the system analysis and then system design, and it will be completed after the system testing, which is in the system development phase. So what is the program documentation? We need the program documentation for the programmers to conduct maintenance or any enhancement, any upgrade to the system in the future. right? So SA will prepare the program documentation, where during the system analysis, we have the process description describing how the process works, okay, depending on the diagram that he's using, the report layouts. And then for the programmers, what they will do is include comments with the programs. All the programs that they develop must include comments. I'm not sure whether this is your own practice, but if it's not currently your practice, I strongly advise you to put comments in your programs. Okay, it's very useful, especially when you want to revisit your codes in the future. Okay, so what are the contents of the program documentation? It might include flowchart, listing of all the codes, the test data, expected result, everything. There are a lot of things can be included in the program documentation, because if there is a system request received to upgrade the system, before we can do upgrading, we need to look at the program documentation. Okay, and then after that, make changes to the current program documentation as well. Okay, let me show you an example. I think I have one example here. We call it as internal documentation, where for a programmer, you are strongly advised to add in the comments. This is, what is this? Yeah, this is using Java, okay? Graphical user interface programming using Java. The one in green would be the comments, okay, to explain the codes. So if you have a meaningful comments like this added into the program, even if you are the one who do the coding, it will be easier for you to recall. Okay, recall after quite a number of years, say, for example, you last touched this program, it will be easier. And then sometimes another different programmer will be assigned to do the maintenance, and he or she needs to look at the program. But then if the program is missing some, what do you call this, some meaningful comments, or worst case scenario, using variable names that are not meaningful, like X, Y, U1, U2, X1, U2, right? It will be very difficult to do maintenance, because you cannot straight away jump into the codes. But the first thing that you need to do is try to understand, what does it mean? What does the code trying to do? Okay. So Farah, Kelvin, and Noel, is it your practice to add in comments in your coding, or you just straight away just type codes? That's it.
Part of it lah.
How about the rest?
For me, depends lah. If it's too complicated already, then I put comment.
Okay, Kelvin.
Never do. Never put.
Never do. Never do. Okay, I think we still have time. Let's see a little bit more. Let me share you my story. When I was still in the industry, okay, I ever work in Lahad Datu. My EDP manager asked me to maintain this particular old system. And then I said, okay. So I take a look at the program, and then I came back to my boss, and then I said, I'm very sorry, but I don't think I can do it. And then my boss, with his big round eyes, looked at me, very puzzled, or perhaps he was angry. So I told him, why don't you look at the program first, okay, before you you say something. And then he looked at the program with his frown face. Yeah. You know what happened? The previous guy before me, the system analyst, he resigned before I joined. He's a very good programmer, and then he resigned. But the problem was all his codes were like Greek to us. It means like the variable names are like X, Y, Z, just one letter variable. There's no comments at all. And program indentation was like horrible. So it's like you're reading, how should I describe that? You imagine all the variables are one letter or two, one letter with a number, U1, U2, U3, U5, okay, and then there's no indentation, there's no meaningful comments at all. And then so my boss told me, all right, how about you develop the system from scratch? So that's happened. If I want to share you this experience of mine to show you the importance of documentation during the system maintenance phase. You want to do maintenance, but is the system itself maintainable? Is the documentation complete in order for the maintenance to be done? Okay, just something for you to think about, right?
Is the code very long?
Sorry?
Is the code very long?
Yeah, it's a whole system. Whole system with the that one, two letters, variables, no indentation, no comments. Can you imagine how horrible that was? Until my boss told me, and he instructed me to develop the whole new system from scratch rather than do the maintenance. Okay, that's a real life experience. Okay, where was I? And the fourth type of documentation so far, what do we have? We have the end user documentation, means the user manual for the end user to do the data entry. We need to teach them how to use the system to enter the data. And then we need another documentation, which is the operation documentation for the operation people, the person in charge to operate the system. And the third one is normally meant for the programmers to do future maintenance. We call it as program documentation. And this is system documentation. System documentation, it begins during system analysis. And it is completed during system design. For the program documentation, we can only complete the program documentation after testing, because after testing, if there's anything wrong, then we need to redo the codes, okay, update the codes, and then add in few more comments. So that's why it is completed after testing, which is in a system development stage or phase. For system documentation, it will be completed in system design, and this time prepared wholly by the SA. System documentation will be used by the system designer, means the person in charge during the system design phase, the programmers, the maintenance programmers. Okay, the purpose is the system documentation, basically what it does is to describe the features of the system. okay, what are the features of the system, and explain how they are implemented. Once like you are the programmer in charge of maintenance, okay, you were not involved in the development of the system previously, but you were assigned to maintain the system. At least you can take a look at the system documentation to get an overall view of available features and how the features are implemented. So you can see like the DD, all right, data dictionary entries. There's a data flow diagram, the user interface design. Okay, the source documents would be if there's any forms that they use to enter the data into the system, and also include the system request form that they receive much more earlier. Okay, so this is system documentation, right? And nowadays, for the software, commercially available software packages, they do provide us with online documentation. Okay, where as long as you have internet connection, you can access this online documentation. And then in this exercise, try to differentiate or compare between these 4 types of documentation. Whenever you see the verb differentiate, compare, it's best to use table to present your answers. Like as we have system documentation, program, user, and also operation documentation. We can differentiate these 4 types of documentation based on who prepared the documentation, who will use the documentation, what is the purpose, and the content. So you can see that basically SA are in charge of all of the documentation. And then for the user documentation, and not user, program documentation, programmers need to include the comments, right? So that's why you can see programmers here. End user, I don't think it's the end user. Let's see, user documentation. It should be programmers, okay, prepared by programmers and SA. So, and this N should be okay, and then used by for maintenance programmers. This one by the users, operation staff. This one used by, I think there's a problem here. Okay, let me copy this. Did I copy? Moment, yeah. Let me do the correction. For system documentation, it should be can be used by all these people. Okay, basically they are meant for maintenance, program and system. User documentation or user manual is meant for training, and operation documentation for operating the system. Okay, so are we at the end? Yeah, we are at the end of our slide already. Okay, any question before I end our lecture?
So far, no.
So
No,
far,
huh?
no.
Okay, so you just continue with the tutorial 8, which we will discuss this day, and also the class activity just now, which is about the feasibility study, and we're done for today. Okay, so I'll see you on Thursday.
Okay, Miss. Thank you.
Yeah, welcome.
Okay,
Bye.
Bye bye.